A blissful welcome and very good evening to one and all present for the fifth day and the last day of the 5 days national level virtual workshop on hands-on SPSS organized by PG Department of Commerce in association with IQAC and Research Cell of St.Teresa's Degree College for Women. I, Navyashri, take the opportunity of hosting today's session. First and foremost, I would like to welcome our resource person, Dr. S. Gokula Krishnan, sir. Wholeheartedly welcome you, sir.
Thank you, ma'am. Good evening, all of you.
Also, I extend my warm welcome to all the participants. Heartily welcome you all, dear participants. Yes, as we all know, today we are at the last day of the virtual workshop. So I will hand over the session to the resource person. Dear participants, I request you to have a active participation and kindly put your queries in the chat box so that I can put forth the same in front of the resource person and get your queries clarified. Well, I hand over the session to the resource person. Sir, you can take over.
Okay, thank you very much, ma'am. And good evening to all of you. I believe everyone is doing well. And let us quickly have a recall of whatever we had experienced it in the demonstration of various tests in the SPSS for the last 4 days and what we are going to do with today. Right from the beginning, we had started with the questionnaire framework. Then we had discussed about the framework of the research, then objectives and measurement tools. Then the steps we had followed for the, so far whatever we have done it is data entry or data loading along with the data coding process. Then we moved on to the formatting of the data, that is through the transformation of the data. And later on we had the demonstration and hands-on training on the validation and the reliability of the data. And then we had missing value handling and analysis, descriptive statistics. Latest we had the factor analysis, especially both the CFA and EFA. And yesterday we focused primarily on the Anova. What are the three different methods of Anova is there? There is one-way Anova, two-way Anova, and Anova also. So we took the following elements to explain how the research question has to be framed and the objectives has to be set off. And what are the major elements or assumptions which we need to look into it whenever we are going for the Anova test. Now, straight away, without wasting much of the time, we will be getting into the correlation, that is measurement of relationship and the impact on the dependent variable by the independent variable, the same thing which we are going to have it. And yesterday I have shown you in the Jamboard also. Hopefully you may remember that how the framework of the conceptual framework of the study it is going to be happen, and accordingly how we have to proceed further. And this is the things which we have discussed so far. Let me get into the measurement of the relationship first. And I would insist all of you to open the data set which you have. Primarily, someone has, I request all the participants kindly mute yourself. Now, let me explain initially what we are going to do it when we are going for the correlation or the regression or any other multivariate or bivariate analysis especially. First thing it is, we know very well that when it comes to this particular data set, the variable, we had each and every variable and it has been measured by the various statements. Okay, when we are going to have all the statements together, okay, when we are going to conduct the correlation, either bivariate or the partial correlation, the matrix goes bigger. So what we are going to do with it is first we will transform the statements into a single variable. That computation I will tell you. Initially we had discussed in the second day itself how to transform the data into statements into the variable. Again, I am going to do that. And after that, once it has been set, the variables has been created based on the number of statements. We are going to execute the correlation analysis. Okay. The prime step here it is going to be first one. Let me mention it here. When we are going to study the relationship, all we must be knowing what are the major things is there when it comes to the relationship things. Okay. So the steps goes like this. Let me explain. First, I will transform the statements, the respective statements, of course, that is very important. It's the respective statements to an variable, okay, to a variable, so that it is easy for me to understand how the overview or overall correlation analysis is going to be useful and the relationship it is going to be that. That's the first step. Second one, as soon as we have done it, we are going to think about the assumptions, which is essential when it comes to the correlation analysis, nor when it comes to the regression also. The third part, the third element, which we are going to focus it is how do I interpret and what are the basics of correlation analysis, the outcome, basic outcomes of correlation analysis. Okay, once we have done it, then we will try to interpret the results, and from that, how we can go ahead with the regression analysis. So this is the complete set of analysis which we are going to do it today. The first step, as I told you, we will be taking all the statements, the respective statements, and converting or transforming into the variables. Then the assumptions we are going to have and basic outcomes of the correlation also we are going to discuss. Then we will try to we will interpret the results. And from the results only we are advised to go with the regression analysis. Normally, there is a provision, it is there in the SPSS without doing the basic analysis of correlation. Yes, you can do it. But whenever we are going to have a traditional method, there itself I can able to filter some variables which is not really having a relationship with each variable, so that I can remove that and I can go with the precised model which is going to be recommended for the measurement of the impact or degree of the impact which is going to be there. That is why I'm going to categorize it into three major parts. This is one part, and these three, that is a correlation, okay, which is comes under second, and finally only we are going to measure the third one. Completely the second step, it is very vital before we get into the regression analysis. It is a continuation. If we break it, then the accuracy and the interpretations may not be in a proper way, what we are expecting. Let me explain how the transformation of the data it is going to happen. That is, variables are going to be created initially. Then we will discuss about the assumptions and then we have go ahead. Okay. So I would insist all of you to open the SPSS data set, which we have been already shared. One thing it is we need to have a clarity which are the variables are available with us and what are the statements are representing those variables that we must have a clarity. So for that, what I'm going to do with it is, let me draw some chart here so that it's going to be useful for all of us. Today I have drawn it. Now again, I'm going to do that because we need to have much more clarity before we'll proceed further. Okay, so I'm going to choose some shapes. Even you can note it down in your notepad or maybe in the notebooks. Okay, in just a minute, I'm creating the model for this particular thing. And if you could able to access the yesterday's Jamboard, that is well and good. No problem at all when you are going for that particular thing. And you can do that. Okay. So let me go with R. Just give me a minute. Probably those who have taken the snap of it, that is going to be useful. Okay. I try with this, otherwise I will go with the Jamboard only, because sometimes still it is not supporting us. Now it is coming, I think it is perfect. Now listen, we have nearly 7 variables. Okay. V1, V2, V3, V4, and so on. Okay. So there are many variables that is going to be there. Roughly, we have told yesterday that one research question, it is going to do with the WLB. Okay. So now my question here it is, this V1, it has been measured by 4 statements as per our data. Okay. Then the V2, it is going to be measured by 8 statements as per our understanding. Okay. So let me go to this particular thing. And here you can see that 8 statement has been measured, measuring the second one. The third one, it has been measured by 5. And the fourth one, it has been measured by, again, 7. And the fifth one, it has been measured by 7 statements. And so on, it is going to be continued. So let us create the transformation, and then we will try to understand that particular context. Okay. Go to the transform menu. This is a fundamental thing. Please try to remember, and accordingly, we have to go ahead further. Okay. Now, go to the compute, that is, go to the transform, compute variable, okay, compute variable. Now, what is my target variable here? It is job autonomy. So I'm going to give AA, for example, the target variable, short form of the target variable I'm typing. Then here, I'm going to give full label name, autonomy. Okay, job autonomy. Is it clear up to this? Each and every step, it is very crucial and essential when it comes to the correlation and regression. So try to follow it carefully. So what I have done it is I have opened the transform. Then I have went to the compute variable and I have typed the target variable, that is JA, in a short form. Or V1 also you can type it, but it is better always we can give an abbreviation. Then type the which one the job autonomy. And here you need to decide whether you want to give a numeric data or string data. It's always better to go with the numeric data. String data, it is not advisable. So this is a thing. So click continue. As soon as you click continue, you need to do what it is. You open or click on the closed bracket. If there is an option, it is available. You can see that it's a closed bracket option. Okay. As soon as you have done it, now you need to carry out the computation. Okay. Very simple. As I have done it in the second day itself. Choose the variables which is representing the statement, the statements which is representing the variable. Click on authority and click here. Plus, just press it plus. Then go ahead with the second variable statement, the third statement. Because we know very well it is only measured by the 4 statements. So as soon as I have added all the statements which is representing JA, I've done this, then number of statements divided by number of statements. Okay, divided by number of statements. Once you are done, click OK. Okay, once you are done, click OK. Once again, I'm repeating. Initially, I have wrote target variable and I have typed the label and I have opted for the numeric data. Then I have clicked on this. Okay, that is open bracket and closed bracket together. Then within the bracket, I have mentioned what are the statements is representing the variable, and I have divided that divided by the number of statements. Just click to OK. Immediately, the output will say whether what you have computed. So hereafter, JA only it is going to be useful. used further for the further analysis. Okay. So how do I understand whether it has been saved or not? Just go to the end in the variable view. You can find it out. The new variable is been formed in the name of JA and job autonomy is there, but there is no values, and scale is by default, it will take it, but there is no values has been given. Okay. So now what you need to do with it is, since we are adopting the same scaling method, all the variables, you can just copy and paste it. Okay. That thing we need to do it. So what I'm going to do with it is, just I will repeat it. I'm going to choose this particular thing because throughout our thing we have used the same thing. Now, copying this, you paste it here. Okay. It has been value has been given. Just to save that. Okay. When you save that, the next thing it is, I need to verify whether everything is coded perfectly or not. Because when we are going to compute the mean, okay, the variable, normally it will comes in the decimals, okay, where it is not going to be represented properly. Okay. Let me show you how it is going to happen. Go to Analyze, Descriptives, and click on Frequencies. You choose only JA. I will tell you what is the difference and how to remove that. Because the same thing it is going to be followed for all. Okay, no, I need not to have any important things actually. So let me choose only few. Especially I need maybe a bar chart for an example, and nothing else is required. Just click OK. When you click OK, you can see that actually ours is only 8. Okay, it is measured in an 8-point scale. You can see that there are subcategories which is there 2.25, 2.50, 2.75. Then somewhat disagree comes 3.25, 3.50, and so on. It is going to be there. So how do I eliminate this? Because when I'm going to take it further for analysis, or when I'm going to present it in the descriptive statistics, the same way I can't do it. Because we have told that all the variables is measured in the same or uniform scaling technique. For this, what I'm going to do with it is, I'm going to use the method called recoding into the same variable. Okay, recode into the same variable. Till now, as of now, any doubts is there, please let me know, because there are hidden procedures and steps are there. Please type it in the chat box because this is a very crucial step. If you are not doing it properly, then it is going to be very difficult. And you will end up in the bigger matrix, and that may or may not be useful, and it will lead to a lot of confusion when you are going to create the model also. Any doubts so far? Else I will repeat it once again, then you can able to understand. Okay, fine. I believe that there is no doubt. However, what I'm going to do with it is, I will repeat it once again so that you will be able to understand. I went to compute variable and target. I have defined this. This I have done it. Then I have taken the closed bracket and the statements representing the variable I have chosen and divided by this. Click to OK. Immediately, this particular thing is open. Then what I have done it is, I have chosen the values which has been represented. Next thing it is, as soon as I wanted to understand whether I have done it perfectly or not, that I have conducted the descriptive statistics, sorry, frequencies. So I could able to find out this is a problem with this graph. So how do I eliminate that? Very simple. Step number 2 in that, go to transform. Please make a note of it. Go to transform. Click on recode into the same variable. I believe you may remember this. Recode into the same variable. You choose the variable which you want to recode it. Okay. N number of variables we can do it, but I'm initially going with the one variable. Then after doing all the things, we will be able to do that. Okay. So I have chosen that. and we can go with this particular thing. Now, the thing it is, we need to understand what are the values has been given for that particular thing. You can see that 1 it is strongly disagree, 2 it is disagree, 3 is somewhat disagree, 4 it's no opinion, 5 is somewhat disagree, 6 it is agree, 7 it is strongly agree, and 8 is not applicable. Do remember this. Now, what I'm going to do with it is the old value I have to give. Okay, old value. This, okay, first thing it is range through, range lowest through till 1.4, for example, 49. Normally, we used to take it as, okay, normally we will take it as 1. So that is a thing. So I'm going to give it as new variable, just enter, add. Okay, so hereafter, whatever I have mentioned till 1.49, it is going to be considered as 1 because I have already coded in that particular thing. Second one, the range which is going to be started 1.5 to 2.49, okay, which is going to be known as 2. This is called recoding into the same variable. The third thing, it is going to be 2.5 to 3.49. Why I'm giving this, it is, this is the problem which we are encountering it. So I wanted to remove that perfectly. So I'm giving 3. Then you can see that 3.5 to 4.49, it is going to be which one? It is 4. And when it comes to this 4.5 to 5.49, it is going to be 5. And when it comes to the 5.5 to 6.49, then it goes to 6. And when it comes to this 6.5 to 7.49, this distribution, it is simple mathematics things only. Normally, we will take it till that particular point. It is going to be like that. So hence I'm using the same method. Now, last one only I'm going to tell you all other values, not all other values actually. It is going to be 7.5. Okay. Onwards, it is going to be 8. Now add this and click continue. And after that, you click OK immediately. That things has been recoded. You can see the message which is popped in your output editor. So now I wanted to understand again whether it has been done it properly or not. So what I'm going to do with it is I'm going to save that data editor, go to analyze, go to the descriptives, frequencies, and choose the same variable. Statistics and everything is fixed up. Now you can see that the entire table it's been converted or recoded in this particular thing. This is the first and foremost thing which we need to do it whenever I'm going to do any computation or transformation of the statements into a single variable. Is that clear to all? Is that clear to all? Ma'am, any queries has been posted?
No more queries, sir. I think it is clear.
Okay. Now, the same thing which we are going to do it for all other variables, then only we can do it. But hereafter, I'm not going to confirm anything. Why? Because I have already done. Okay. So I know how to do that. Hence, I'm not going to do that. So I'm going to do the next one, compute variable. What is the second variable which has been there with us? It is work family conflict. So what I'm going to do with it is WFC. And here I will type full name of it, work family conflict. Okay. And you remove entire thing again here. Now I wanted to understand which are the variables has been taken. Let us go back to my coding sheet. Okay. It is from inference to force to save. Okay. So I'm going to have inference Even if you double click also, it will work. You need not to, every time you need not to go for that. And that is why this Excel sheet was carefully coded. Okay. Even by mistake, if you click it also, these things will not be happen. Now you can see that I have chosen one wrong thing. I'm deleting that. X5 it has been done. Then X3, B6 has been done. So I know it is only 8. So let me put it here. Okay. So how many variables it is there? Statements is there? 8. So hence I'm going to do that 8. It's done. Now the next variable, I'm going to take it, computing the variable. Similar to that, all the things we need to do it. Then only your data would be ready. Okay, OC. So let me copy that OC alone. And how many statements? It has 5 statements. Okay, where is the outcome? It is there. So I'm typing it the short forms. Here, let me give the full name of it. New. And again, I'm going to delete completely. Why? Because then only we can able to understand. So X3C1 plus 5, I think it is. Let us go ahead with that. Yes, I think only 5. Let me check it out. Yes, 5 statements contributing this variable. And I have done that. Again, as usual, I'm going to do this particular thing. Click OK. Computation alone, you can't do it for multiple things. One by one only you are instructed to do. Then only you will have clarity what you are doing it, and you will not miss any single statement in that particular process. Now OC is done. Okay, that is organizational commitment is done. What is next? We will look into it. We have work exhaustion. Okay, so let me choose WEV. Okay, I will use the short form V, and here I'm going to type it. I believe everyone is doing it. If you are not going to do, then I don't think so. You may be able to understand what I'm trying to convey. Totally 7 statements here. I'm going to choose it from here. Yes, 5 is done. So I have to choose it exactly which one it is going to be started. Yes, it is done. Yes, I have to click. Yes, here also plus. Even sometimes we can, if you know the code exactly, you can type it. Nothing wrong in that. Okay. Every time going there and doing that, instead of doing that, you can straight away you can type it exactly, but without changing the small capital number and block number and so on. The letters exactly you need to type, otherwise it will not come. Okay, it is 7 statements if I'm correct. It has been done. So click OK. Then another variable also is computed. So let us go to the next variable. Okay, compute. Now, as many variables you have, accordingly only you have to go. Okay, normally it is advised that you need to go like that only. Okay, this is perceived workload. We have only 7, but some cases you will have more number of variables. By the time you need to be very careful. Okay, perceived workload. So I'm going to EWL. I'm clicking, and I will be typing it here. And as usual, how many statements is there? For 7 statements again. So let me choose the next one. It starts from X3E1, if I'm correct. Okay, yes, this is the first statement. Second one, third one, fourth one, fifth one, and the 6th, and the last. That are 7 statements. Hence, I'm concluding here, divided by 7. Click OK. So now almost we have done with 5. Okay. Then the next thing it is we are going to have, it is the fairness of rewards. Okay. So let me go to transform again, compute fairness of rewards. FR I will give short form, because the short forms also will be useful for us when we are going to do it properly. Okay. And here it is, many statements are there. Let me show you how we can write it directly so that it will compute the thing. Instead of deleting, I'm going to use F, but not capital, it is small f. There's only 6 variables is there, F3. This method also you can follow if you have a confidence on it. Otherwise, you can directly go for the things. Okay, delete and then click on 6. You can go ahead. So 6 variables only, but make sure that the coding should not violate. Okay, otherwise it is going to be very difficult. It will take some other data and it will compute. Okay, compute. And we have done almost 6 things, and we have left with another 2. Okay, another 2. Last one there is no problem because we are not going to compute everything. Only this one we are going to compute. Okay, because as per the questionnaire, only one question was asked. Hence, there is no problem at all for us. So this is the last one. I think turnover intention, TI, I am going to mention. Okay, here I will paste the value over intention. So how many statements has been used for measuring this? 5. So I will use G here. G. If you have a confidence, just use it. Otherwise, it is go with the regular or traditional method. Okay, because it is consuming more time, and so I'm doing it. So we are done. Okay, almost we have computed all the things. You can see that in the output, it is given very clearly all the things it has been computed. Okay. Now the next question it is, yes, do I need to do that, sir? Yes, we need to copy and paste it. Okay. All the things. Let me paste it. So it is done. As usual, as I told you, the things will not be in a order. Again, there is a shuffling and this that. So let me recode into the same variable. Okay. We'll choose all the variables, whichever we have decided, right from this to this. Choose this. Already I have done this, hence it is not required, because that is why I have kept it this variable also. If you remove this variable, again you need to do it from fresh. So I click OK. Immediately the recoding of the variables has been done. So you are done with the things. You are done with the things. Now, finally, what I'm going to do with it is let me bring all the variables together so that it is going to be easy for me for doing that. Okay, cancel. Recode into different variable. I'm going to choose it. That is the last one which we are going to use it, the perfect work-life balance. Only thing it is I'm going to change name alone. Okay, perfect work-life balance for our understanding. Again, perfect work-life balance. Okay, and then as usual, you know very well, same values only we are going to use it. 1. Okay. Otherwise, you can copy and paste it. That's not a big deal in this. So all the variables together, it is always better. Okay, it doesn't mean that it is required. It is not mandatory also. Please try to remember, it is not mandatory. Then 6. 7 is equal to 7. Because I want to bring it in new context. Sometimes, no, when we copy, that will not carry out the purpose. Okay, so we will do that, and accordingly we can change comments. One more is left out, I think, so that's why it is not coming. 8. Add, and click continue. Same thing I have given, hence it may not come. We can do it as we'll use 0. Change and then click continue. Then if you set on that things, you can able to understand how it is going to happen. Once you are done, you can get the variable here, but now it is taking time. So hence I'm concluding here. Okay, I'm not going to touch it. Now we'll go to the which one? The transformation of the data has been done. Now we'll move on to this particular thing. So I have transformed the respective statement into the variable. Okay, I have created. Now I need to go ahead further on this. Now my objective here it is to understand the relationship between the variables. Okay, let us understand the assumptions of correlation. Okay, is there any doubt so far before we'll proceed further? This is a second step when it comes to the measurement of relationship. Is there any doubt?
I don't find any query in the chat box, sir.
Okay, shall I proceed further?
Yes, sir.
The assumptions, it is very simple for both correlation and regression. Variables must be in continuous scale. Continuous scale or variable. Okay, that we know very well. No, continuous means either in interval data or in ratio. No other scale technique we are not supposed to use it when it comes to the correlation. Please make a note of it, even for the regression. And second assumption, all the variables must be measured in same method, which means 5 point means 5 point, 2 point means 2 point, or 7 point means 7 point. That is the thing, same thing it has to be done it. Okay. These are the two major assumptions we need to remember. You know, the outcomes of the correlation, either we will get positive correlation or negative correlation, that and all you must be knowing, and zero correlation. Normally it won't occur. Okay, it will tell you whether it is going to be in positive correlation or negative correlation. So finally it is going to be there. So what we will do with it is, before going to the regression, we will remove the negative correlated variables, okay, from the list, and then we will perform the regression so that the precise model it is going to be useful to study the degree of impact. Okay, so this is the basics of correlation. There are two methods is there. One, it is bivariate correlation and partial correlation. Okay, both the things it is going to be useful. In general, we can find it in any article. Majority of the articles will use bivariate correlation only. Let me tell you how it is going to be happen and everything. Go to analyze. The algorithm for correlation. Go to analyze. Click on correlate. Click on correlate. Then bivariate. Again, I'm repeating. Correlation analysis. Go to analyze. Correlation. That is correlate. Click on bivariate. Okay. Now, as soon as you opened, clicked on it, you will get a dialog box, bivariate correlation. Now, please try to remember, when it comes to the correlation, we won't consider the variables, either it is dependent or independent. But however, as per our framework, we will try to compare the results only with dependent variable. Okay. Now we have all these variables. Our research design says that we need to study with this particular variable. So I have chosen. Let us assume that this is all about perfect work-life balance. It is a dependent variable, rest all independent variable. In the yesterday's discussion, I have told you. Okay, as soon as you have done it, you have executed the variables into the variables list, go to the options. Here you can decide what kind of statistics you want to have. Normally we have means and standard deviation, am I correct? So that is always better. In case you are in need of cross product deviation and covariance, you can go for it. But for the HR and marketing data, it is not required. But when it comes to the time series as well as the financial data, it may require, okay, econometrics and all. So we will touch only with the means and standard deviation, and missing values as usual exclude the cases pairwise. I'm clicking on that. Once it has been done, you're almost through with the correlation. Now, another thing, you can identify that the correlation coefficient is there. There are three methods has been given. One is Pearson correlation. Okay. Another one is Spearman correlation, which speaks about the rank order, and Kendall's taboo correlation. Again, it is another author who contributed towards correlation to find out the association between and among the variables. By default, the correlation coefficient will enable Pearson correlation only unless you are changing it. I would suggest you that when we need to choose the Spearman means when I'm having an continuous variable which is ranked. Continuous variable which is ranked. By the time only I need to go for Spearman. Otherwise, please don't choose the Spearman rank order correlation. It is by default itself rank order. And when it comes to the rank order correlation, by default, one variable must be in ordinal scale. Please make a note of it. One variable must be in ordinal scale. The rest, it could be in continuous scale. Okay. But in general, Pearson correlation and Kendall's method will entertain only continuous variable into the analysis. This is the clarification or clarity which you need to have before you are going to do it. Even if you are not doing anything also, it will take only Pearson. Next thing, it is about the test of significance. Two-tailed or one-tailed. We will go with two-tailed only. We won't rely on that one-sided, one-tailed method. Okay, because eventually we wanted to understand the data is distributed normally. And one more important thing I have not told you, the data must be normally distributed. Continuous variables which we are using should be normally distributed. If in case if it is not normally distributed, again it will disturb the results of correlation as well as regression. Okay, so these are the points you need to remember when we are going to execute the correlation analysis. And I'm repeating, go to the analyze, click on correlate, then bivariate. The bivariate correlation table has appeared, dialog box. Then choose the variables which you need to do it. Already we computed and kept it. So I have executed and then I kept it in the variables list. Then click on the option. I have chosen only means and standard deviation. It's a fundamental one. Then Pearson. So by default, it is going to be there because I'm not using any ordinal or rank order scale. Hence, I'm choosing that. By default, it will come. And flag significant correlation, which means it will tell you it's significant at which level, 0.01 level, 0.05 level. That machine itself will consider. You need not to worry about it. Okay. Once you are done, you are okay to go with results. Just click results. Immediately, you will get the results this. Okay. And correlation table also has come. You can see that it has been appearing here. All the variables are coming here and it is showing. Okay. So what I'm going to do with it is I will be showing how it is going to be. Let me minimize this gap so that the entire table it is going to be visible to all of you. Okay. Any doubts in terms of execution of the correlation, bivariate correlation? If you have, please let me know before we'll get into the interpretation, how to do the analysis and the interpreting and how to remove the variables which is not positively or significantly correlated with the particular dependent variable. Okay.
No doubt, sir.
Fine. So now we can able to understand there are variables which we have listed. Job autonomy is there, work-life conflict is there, organizational commitment, work exhaustion, perceived workload, fairness of rewards, turnover, perfect work-life balance, and on. In our model, okay, in our research question, our intention is to study the relationship between perfect work-life balance with the work-life balance factors. That is what we have framed it. Okay. So what I will do with it is, I am going to consider only this row or this column. Okay. I will not going to consider what is happening with this particular complete data set. So what I am going to do with it is, now I will export this data to some other Excel sheet so that I will tell you how you need to present it also. Okay. I'm choosing only that selected thing. You can see that the selection has come. We'll click OK. Okay, not in descriptive thing. Let me create one more thing actually. Just a minute, I will browse it properly. So we'll go to the desktop where I have saved the complete detail, and in that the college name is there. So here I'm going to type it. It is going to be correlation. Okay, for example, click OK, save, and click OK. Immediately it is getting exported. Now we'll get into the Excel spreadsheet that you will be able to understand how the things is going to happen. Okay. Why I'm not explaining with the SPSS it is, some points we need to highlight it. With the help of Excel, yes, I can able to highlight it. That's why I'm switching into the what do you call Excel sheet. Okay. This is the things that is available to us. It has been already exported. Okay. Now I will zoom in so that it is going to be fit in the same page. A little bit we can go ahead. My intention here it is to understand only about this. You can see that on the bottom of the table, there is a one asterisk is there, sorry, star mark is there. In second, also two things is there, which indicates at which significant level that point has been correlated, which significant level that point it has been correlated. One star, if it is available, that is going to be significant at 0.05 level at the two-tailed level test. And when we have two stars, that is going to be significant at 0.01 level. That acceptance and rejection area and the conditions you must be knowing. Now I'm going to elaborate it how it is going to do it. So in order to make it clear, okay, what I'm going to do with it is, I will make it smaller, but it is going to be visible to all. Okay. And the data also, because when we are not able to focus, okay, zoom in, then the explanations may not be good. Okay. So I have done it. Now I can zoom in so that it is going to be fit in a single row. I would suggest always to remove this, what do you call, the n, that is number of things. Okay. Because this is called the way of presentation. Before we'll go, it is better good to go with this. And it is going to be minimized when you are going to arrange it in your Word document. You need not to worry. On the bottom, you can mention what is the n, that is sample size you have chosen for this study. Okay. However, you must have mentioned it in the research methodology, hence it is not required to repeat it. Okay. This is how is there. As I told you, here I'm going to choose only this. This is my dependent list as per my research question. Now you can find it. There is a one, that is one same variable, it is correlated with the same thing matrix. There's going to be one will come. I would suggest you to remove this. This is how maximum number of authors will present their data. Okay, directly from SPSS you can't do. However, as I told you, the Excel is the mother of all analytical softwares. Okay, so this is always better to remove, and it will remove the space also, the alignment issues also for us. Now I'm going to take only this values and I'm going to interpret. I'm going to interpret. Now let us make it clear. Okay. I'm able to see that the first point it has been there, perfect work-life balance versus job autonomy. Let me write it here. How do I interpret? So I will check it JA with PWLB, perfect work-life balance. Okay. Now I need to decide whether it is accepted, significantly correlated or not. Then I will tell what is the strength of correlation and what kind of correlation. Okay, those things I'm going to tell you. First, what I'm going to do with it is, now you need not to do this, but since we are doing it first time, I would suggest you to have this. Okay, the type of correlation, it is going to be there. P-value, R stands for correlation coefficient, type of thing, and the hypothesis. Okay, hypothesis accepted or rejected, whether H0 is accepted or rejected, that is what it is going to be there. Second thing it is, we will be going for WFC versus PWLB. Okay, the same thing it is going to be carried out for all other 1, 2, 3, 4, 5. Let me copy it. Okay, so immediately we can minimize our time. Reverse it. OC, PWLB, and here it is going to be next one. AP work exaction. Then this is going to be PWO. Okay, perceived workload. I think I have mentioned PWL in the SPSS. However, it is okay. FR. Then finally turnover intention. TI. This understanding you need to have. So what I'm going to do with it is I'm going to copy all the values. When you look at this, okay, all P values you can have and copy. Okay, and here transpose. It's very simple. Go for transpose so that it will come in a sequence. Okay, so I have done that. Then we are going with the values because that is very important. Even though you need not to present the entire correlation table when your paper, the instruction says that you need to give it within 7 pages and all. By the time this method, it is going to be very useful for you to write and present it in a crispy manner and precise manner. I have done that. Okay, I have done that. Now I need to say that whether it is significantly correlated or not. Whether it is significantly correlated or not. Okay. Back, I'm going to insert one more column here, that is significant. Okay, significance. Significance. Okay. Now, as you know that everything is, we are doing it under. Okay, everything we are doing it under 0.05 level. Okay. By default, it will take that one only. And when it comes to the 2-star, okay, 2-star, as we have looked into it, it is significant at 0.01 level. If it is in 1-star, it is significant at 0.05 level. So that you need to remember. Now, the p-value, okay, the p-value, you can find it out, 551, which is not significant, which is greater than, okay, which is greater. Okay, so it is not significant. You just write it like this. When it comes to this, yes, it is significant. Yes, it is significant. Okay. Yes, this one also significant. There is no doubt about it. Let me copy and paste it. This one also significant, and this one also significant, but this is not a significant one. So I'm going to mention it, not significant. This clarity we need to have. First and foremost thing, it is p-value. You can identify that these are the values are not significant, so I'm unbolding it. And what you can do with it is, from your analysis itself for the regression, you can remove this variable. Okay, because the model fitness will not be affected when you are going to remove the non-significant variables. Okay. As per the literature, it may support. And when it comes to the regression, it is all about how much degree of impact has been made by the independent variable on dependent variable. That is how it is going to come. Our prediction has been done. Hence, I would insist that you need to remove this. Okay. Next thing it is, let us understand. If it is not significant, you need not to consider whether you wanted to go with whether what type of correlation it is. Just mention any, because it is not required. No, so we are not going to do that. Now, the next question. It is significant. Please try to remember it is significant, but in which thing it is going to be? You can see that it is positively significant. So it is a positive correlation. Just mention positive. But here, when it comes to this negative, why? Because the sign is there, then here we can say that it is again positive. Again, it is positive, and this one also positive. Okay. I hope it is clear to all of you. Then hypothesis, I will say that H1 is rejected. No, let me use only H1 rejected or not. Okay, we will use reject H1. Okay, now always better. This is accept H1. So here accept, here also accept, here reject, here accept. By looking at this, I can able to write complete interpretation stating that which are the variables are having a significantly correlated and positive, so on, and which are the variables are rejected. Is it clear to all of you? Do I need to repeat it once again? Any queries? Yes.
There are no queries, sir. Hope it is clear.
Ask them, madam. Otherwise, you yourself and myself going to be there probably.
Kindly respond, dear participants. You can unmute yourself and tell that there is no more queries, or you can ask your queries if you have any. Or you can even put it in a chat box. So there's a question from Vijay Shri.
Yes, please.
So repeat, sir. Kindly repeat it once again.
Which one, ma'am? Just tell me, because I have covered almost everything. Which is required?
Ma'am, can you be precise enough? Which part you want to repeat once again? You want sir to repeat once again? Vijay Shri, ma'am, you can unmute yourself and tell which part you want sir to repeat once again. Interpretation last table, sir.
Okay. Just a moment, ma'am. I will explain to you. Okay. This table, am I correct? That is what they must be expecting. Now, let me repeat it once again. What I have done it is, I have already set the objective, which I wanted to understand the relationship between the factors of work-life balance and perfect work-life balance. So hence, I have chosen only work-life balance with all other variables. Is that clear? Then what I have done it is, after that, have copied all the p-values. Okay, have copied all the p-values, that is significant value which has been mentioned. You can see that 0.551, 0.008 and everything. Then I have created whether it is going to be significant or not, then R also. Okay, So these are the 5 things. It is always better to keep it in mind so that when you are going to write an interpretation, you can write it. So here, as usual, it is greater than the 0.05 level, so it becomes non-significant. And it becomes non-significant, the type of correlation also it is going to be not applicable. And by default, I'm going to reject the alternative hypothesis, which means there is no significant correlation or association between job autonomy with the perfect work-life balance. Okay. So when it comes to the second one, how do I interpret? I will interpret there is a significant. Why? Because it is positive as well as significant, and it is, I have accepted the H1. So what I will do with it is I will mention it. There is a significant relationship between work-family conflict and perfect work-life balance. And it is positively correlated. That is how we are going to write it. Okay. Now, however, what I will do with it is I will type it for your understanding. There is no significant, because it is very important, significant relationship or association between AA and P, that is perfect work-life balance. Okay, why? And also we have to mention it. It's always better mention value, that is P value, it is 0.551, which is much greater than 0.05. Colon. Okay. In this itself it is run, but however, we will mention the R value also 0.70. Okay, hence I am summarizingly I am rejecting that. Okay. And similarly, I am going to do the second one. Here, what I will do with it is I am going to have the JA, instead of JA, it is going to be work family conflict, where there is a significant relationship. But when you say there is a significant relationship, okay, we need to mention whether it's a positive or not. There is a positive and significant relationship between the WFC with this, and I'm going to mention it is going to be in continuous what do you call statement. You can't split it out as a bulletin points. It is a running thing only. Okay, so it is lesser than. So I am mentioning R value. Whenever we are going to do that, you need to be very careful. Why? Because you need to use this thing. Okay, at which level also you have to tell. Okay, at which level. I'm going to copy this, and at it is 2 stars has come. If I'm correct, 2 stars are significant at 0.01 significant level. So this is how the entire thing we will do it. And by when you look into the interpretation after this table, you will get completely know that how it has been done. So this is the best method I would suggest when the number of pages of the article it has been asked to reduce for the minimal pages. In a one side, 2 columns. One side you can keep only small table, and another side you can give the 5 or 6 statements together as a paragraph, and you can conclude it. Okay, is it clear to all? Clear to all? Shall I proceed with the regression, because it will take much time? You know, almost now itself 6:40.
Yes, sir, it is clear. We got a response.
Okay. Now, when I'm going for the regression, okay, when I'm going for the regression, I need to, as I told you, I can't carry the variables which is not significantly correlated. When there is no correlation, why should I study about the impact? Am I correct? So normally linear regression X on Y or Y on X, it is going to be there. I believe you may remember. The formulas also you must be new about it. Okay. Let me insert a formula and I will tell you how it is going to happen. Okay, just a minute. I need to go to insert, symbols, equations. Let me choose some simple one, then accordingly we can go ahead. Wait, it is loading. Okay. Here, which sheet I was using, I confused. Relation sheet only. Yes, we got this. I have to keep it separately. And I will maximize it. Why? Because that is going to be useful for us. Now, you know very well what are the major things is required. Y, that is the independent dependent variable. Then beta, sorry, alpha. Let me insert the alpha from equation. Okay, here going to be there. Just a minute. Where is the alpha value? It's here alpha plus beta of x1. X1 means here is all about the variable 1. Okay, x1. Let me make it x1 plus this formula. You should create it before we'll proceed with the regression. Okay, just a minute, it is pasting it. Okay, beta 2. So how many variables you have, accordingly you have to put. Okay, put and standard error. Finally, the standard error, it is going to be measured. So this is the regression equation, and I hope you aware, all of you. Okay, so I will tell you what is what. Y stands for dependent variable. Okay, dependent. These things you need to have a clarity. Dependent variable. Okay, then alpha. That is alpha. It is known as intercept or constant. Constant value. Okay. Then beta. Beta value, it is nothing but beta x1, unstandardized coefficient value. Unstandardized coefficient value of x1. X1 means variable 1. SE stands for standard error. Normally, any regression will allow the standard error. Okay. So this is the thing which we need to have a clarity. Now, I need to decide how my the correlation will help me out to frame this model. As usual, we know very well PWLB is an variable, dependent variable. Here, first one, it is not supporting. Now I'm going to mention the constant directly. Constant plus, it could be plus or minus, but we are not going to decide now. Later part, when we run the regression, we are going to have it. So WFC, this is model. Okay, WFC, then OC plus WE plus TWO plus TI. So this is the model plus SE, standard error is going to be there. Okay, SE. This is the regression equation which you need to remember when you are going to proceed further. What I have done it here, it is, I have removed these two variables. Is it clear? Any doubts in this? Any doubts in this? Now I'm going to take only the variables are significantly correlated. Rest of the things I'm going to remove it from my study. Okay. Till the end of your research, that analysis, you can't finalize any variable. After doing the analysis, accordingly only you need to rewrite your entire thing. Okay. Is it clear, all of you? So that I can proceed further with this particular data set. Yes or no? Any queries or any doubts?
No queries, sir.
Okay, I will proceed further. Now go to the, as usual, let me close this correlation dialog box because we are going to save it in regression separately. Okay, it is going to be correlation analysis. What happens now when you are not saving it individually, it will load there only. So in order to avoid some confusions, I have taken. So go to analyze, starting the regression analysis. It is applicable for multiple and simple regression, everything. Okay. Go to regression, analyze, go to regression. Normally we will go with the linear regression. Okay. Linear regression. Click on linear regression, linear. Again, I'm repeating because the steps are more. Please make a note of it. Go to analyze, regression, go to analyze, regression, click on linear. Okay. Now I know what is my dependent variable and what is my independent variable. Let me choose my dependent variable, that is perfect work-life balance. Perfect work-life balance. Okay. Now the second one, I need to know what are the independent variables I'm using. So I have already computed and kept it ready. Only thing it is, now I can't take everything together. As I told you, I'm removing job autonomy because it is not significant, and FR, fairness. Okay. So I'm going to remove. So now you can see that. Now you can see that only work-life balance, WFC, OC, WE, PWO, and TI it is going to be there in my thing. Okay. So this is the first step which we need to do it. Okay, which is the first step which we are going to do it. Now, next thing it is, I need to define which method of regression you want to go. Okay, which method of regression you want to go. There are many methods there. You can see that one it is enter method. This by default it would be there. This is stepwise method. I will tell you later how it is going to be. Remove, backward, and forward method. These two are maximum used. Many authors will be using. Let us go with the enter method by default. This is the third step. Go to statistics table, statistics option, statistics option. Okay. Here by default, regression coefficient will enable the estimates. There is no doubt about it. Now you leave it as such. If you want to change the confidence interval, you can change it, or else you can leave it. But here on the right side, you need to enable a lot of options. One it is model fit. By default, it will check whether the model is fit or not. Then I wanted to understand R square change, the descriptive statistics table. If you want to have part and partial correlation, you can collinearity diagnostics, okay, if it is required. However, I'm going to check the collinearity also here so that you will have a better understanding. Part and partial correlation, why I'm not choosing it is already we have explored the correlation associations and all, so I'm not going to use it. Residuals, in case if you want to use it, you can go with the Durbin-Watson method, okay, or case-wise diagnostic. But now I'm not going to touch with the residuals. Okay, click OK. Once again, I'm repeating. I clicked on the statistics option, then regression coefficient option, and under that estimates I have chosen. Then model fit, R square change, descriptives, and collinearity diagnosis I have chosen. I have left with the part and partial correlation. Continue. Go to plots. This one, what do you want to have? Either you wanted to have a scatter of the diagram, or this is a model actually. Okay, various linear models is there, but it is not required for us. We will straight away go with normal probability and histogram. Normal probability and histogram. Standardized residual plots. Under standardized residual plots, I have chosen histogram normal probability plot. Okay. Continue. Click continue. Then go to save option. Here, this is another important box. Okay. Under the predictive values, please make a note of it. Under the predictive values, I'm going to enable unstandardized predicted values. Adjusted standard error mean of predictions, I'm not going to calculate. I'm not interested in that. If you want to have, you can. But predictive values must have unstandardized and standardized thing. Here I'm going to choose the residuals. unstandardized, and standardized. Standardized and standardized. Rest of the things you can leave it as such. You need not to touch anything. Again, I'm repeating, under the save option, unstandardized predicted values and standardized predicted values I have enabled. Then residuals, unstandardized and standardized values I have enabled. Click OK, continue. When you click continue, then the next thing it is you need to go for options. By default, leave it as such. You need not to worry about anything. Okay. So these are the steps you need to follow it when you are going to perform linear regression. Again, I'm repeating, please make a note of it. Go to Analyze, Regression, Linear Regression. Then you will get this dialog box. I've chosen a dependent variable. Then I have chosen the relevant independent variable based on my correlation analysis. By default, I am allowing enter method. This is method 1. Okay, method 2 also I'm going to tell you. The second thing it is, after that, I've clicked on statistics option. Regression, estimates I have chosen. And I have enabled model fit, R-square change, descriptives, collinearity diagnosis. Continue. Go to plots. Here I have enabled only standardized residual plots, histogram and normal probability plot. Continue. Under the save option, I have enabled unstandardized and standardized options for residuals as well as for the predicted values. These are, it is important one. That is why we are taking this. And options, go to the options, nothing we are going to do. That's it. And click OK. Is there any doubt in terms of execution of the results so far? Is there any doubts in the residue doubts, ma'am? Any doubts in the chat box?
No, sir.
Okay, now I will click OK, and immediately your regression appears on your output editor, output viewer. I believe all of you got the results. Okay, right from descriptive statistics table, correlation matrix table. Okay, then you can see that only it goes with this variables entered and removed, model summary table, Anova table, coefficient table, and collinearity diagnosis table, and residual statistics, then histogram and normal probability plot. Okay. So these are the things that is very important so that you can able to understand how the impact has been made. Okay. I believe everyone got the results. Okay. Let us go to the interpretation. How do I start this interpretation? And what are the major things I need to look into it? First thing, you need to go to variables entered and removed table. Let me type it in Excel so that you can also understand the regression interpretation. This is a step procedure we need to go for it. Step 1, variables entered or removed table. Okay. Second table, please make a note of it. Anova table we need to go. Third one, okay, let me show you. Third one, we need to go to model summary table. Summary table. The fourth one, table which we need to look into it is coefficient table. Coefficient table. And fifth one, in case if you want to go with the collinearity, then you can, okay, collinearity. If not, we will go with this one, normal PP plot. Normal PP plot. Normally, we won't go with the collinearity unless it is required. Okay, have you noted down all these things? because each and everything we are going to understand, and what are the values you need to look into it when we are going to interpret the results, and what is the outcome also I'm going to tell you. So uses of this table, first let us understand. This table, okay, variable entered and removed, let me show you. This will confirm what are the variables we have kept it. What are the variables we have kept it, and the method which we have used it. Because we need to confirm it once again. By chance, sometimes we may included some other variables also. That will affect again the results. So it is always better to go ahead with this verification. So I'm checking, verifying the variables which has been used for the model, for the regression model. That is the purpose. Okay. Verifying the regression model. Next one, Anova will confirm and validate the model. Anova will confirm, validates the model. Again, in Anova, we have some values we need to look into it that I will tell you. Just I will insert a few more table. What are the values you need to look into it, and accordingly we need to go for it. The value which we need to look into it is first p value, and second one f static value. Yesterday we have discussed the same thing, it is going to be there. And model summary table, okay, which tells about the degree of prediction nor degree of impact. Okay. So here we will normally consider only one value, okay, that is r square value. R square, let me write it, r square value. I will tell you how it is going to happen. In the coefficient table only, we will have more values. Okay. I believe everyone is noting it down because it is explaining itself, it will take time. Okay. In a coefficient table, the formula which we have created, formula is going to be validated here with this using. Here, what are the values we are going to use it as? I will show you. When you go for this, you can see that first we will have constant value. Constant value. Okay. Then second thing it is, we will be going with significant value of p value of independent variables. P value of independent variables, IDVs. Let me make it like that. The third value which we are going to look into it is the T static value. Please make a note of it. T static value. T static value for all IDVs, number of IDVs. Okay. Then one more thing also we are going to look into it. Two more, if I'm correct. Two more. That is, one it is about unstandardized coefficient value. Unstandardized coefficient values for again IDV. All IDVs is going to be taken. Last standard error. Standard error value. These many values you need to keep in mind when you are going to do it. The normal PP plot will tell us how the degree of impact has been made. So just you can present that what you call graph, and then you can leave it. Need not to explain everything. Is that clear so far? No, this will take time. Just I wanted to understand, is that clear? Every table and values, uses and the values which you need to consider. Is it clear? Any doubts in this? But I will proceed further in this thing.
Hope it is clear, sir. You can proceed.
Okay. Now, First thing, as I told you, I will be checking with the variables removed and entered. So there is no problem for me. Here you can see that dependent variable has been mentioned very clearly, and B, all requested variables. B, it is always nothing but it is an independent variable and so on. Now, as I told you, we'll go to the Anova table. We'll check it out. First thing, you can see that what is the significant value is available. In our model, it is significant. Okay, it is model is significant. P-value says here, this model is significant. Why? It is 0.00 is less than 0.05. Hence, what I'm telling, model, the created model is significant. Significant. Next one, as I told you, I wanted to understand whether it has been validated or not. Subsequently, yesterday I have told you, no, it must be about 2.46 when it comes to the 95% confidence level. In our case, it is 18.904. So let me type it, 18.904. It's much greater than 2.46. Okay, now let me write it here. So what is that? Model is validated at 0.05 significant level. Significant level. Okay, 0.05 significant level. Now, once, please try to remember, if you get clearance from Anova only, you are supposed to go to the model summary table. If anything goes wrong, let us say that model is not significant, means there itself you need to conclude that the proposed model, it is not supporting your hypothesis. You're getting my point? Once again, I'm repeating, if p-value is not significant from the Anova table, means there itself you need to stop your further interpretation. Okay. Once the model is significant, then you need to go for validating, and then only you have to go for prediction. Is that clear to all? It's a flow. Without this flow, you are not supposed to go. Okay, this is a flow. It's supposed to go. It's something like an checkpoints. Okay, one check, if you cross that level, then second level, third level, that is how. If you fail in first level, then again you have to redo and rework about your variables and what is the data and problem and everything. You need to look into it, and accordingly only you are supposed to go. Okay, and again, there are a lot of factors is there. The first factor, it is validation. Second one, it is about your reliability value of each and every variable which we have finalized, that we have done it, no, first, second day itself. Everything we need to keep in mind, and accordingly only it goes. Since I have done everything, so the perfect model, it is coming now. So now the next thing here, the degree of prediction, okay, how it is going to happen. Here only one value we are going to think about it, that is R square value. Okay. How much it is there? R square value, not R value, it is R square value. It is 0.523. 0.523. Okay, let me make it 523, which means we can convert this into percentage. Okay, is equals to, let me put it, and let me use percent. So it is 52% is been predicted by dependent variable on, predicted by independent variable on dependent variable. Is that clear? My model, my proposed model is 52% validated, which means, once again, I'm repeating, 52% is predicted. 52% is predicted by IDVs on DV. That is dependent variable. In our study, using these four different variables which we have used it for this, it is predicting 52% of the prediction has been done on perfect work-life balance. Is that clear? Almost your regression analysis complete outcome is being interpreted. Okay, the rest it is going to be all about that what do you call formula and model, how it is going to fit. Any doubts in this? In case if it is here, let us imagine that it is 0.7, 0.8 means 80%, 90%. That is how it is going to come. But normally 0.93, okay, 0.93 and above, it is not advisable, which means some problem would be available with your data. Normally, exactly it won't fit. That also we need to understand. Any doubts in this? Any doubts? And you can ask me, sir, either if it is comes below 0.5 or something like that, sir, whether we can proceed further or not. I would suggest you that you recheck your variables and the data. Whenever we are going for the publications, no, people will expect a minimum 0.5 and above. Okay, or some cases, no, extraordinary cases, we will even look for the 70% of prediction. Then only that model is going to be used by the other people also. And I have told you, no, in the first session, the citation, all about citation. When a researcher, future researcher in your field of study, someone is reading your article and they're finding that R square value, it is very lesser. They may not get the confidence that whether should I cite your article or not. That much impact is there. Is there any query in this before we'll proceed? I don't think so. There is a query. So let us understand. Yes. Anything is there, ma'am?
No, sir.
Now, let me go to the next thing, constant, that is coefficient value. Here, constant value, please try to remember, this is the constant. Unstandardized coefficient value is there, no? Minus 1.205, okay, minus 1.025. That is a constant value. Please make a note of it. Minus 1.025 is a constant value here. Okay. Now, how many IDVs we have? We have 1, 2, 3, 4. 1, 2, 3, 4. So all the values we need to remember. We go to the significant level. Okay. One it is work family conflict 0.377. The second one it is 0.681. Third one 0.211. Then the last one 0.000. Now, okay, 0.00. Now you can understand that only out of these three, out of this four, these three are not significantly predicting. These three are not significantly predicting. Why? Because it is having a significant value of more than 0.05. Only one value it is predicting here, one variable, turnover intention alone is predicting. Turnover intention alone, it is predicting this model. You can see that standardized, unstandardized coefficient value also 0.847, which means if this is the highest predictor. Now, how I am going to tell you it is, with P static value, you can look into it. Higher the value, higher the prediction. Higher the value, higher the prediction. First condition, as I told you, the significant level must be there. Then the P static value has to be added, and accordingly we can go forward. So our conclusion would be this is only which one is predicting significantly. Turnover intention alone is predicting the perfect work-life balance. No, because that is how the data was given. It doesn't mean that the others are not predicting. Based on the data only I'm speaking about it. So the unstandardized coefficient value, beta values has been given here. You can make a note of it. And it is not there. You need not to mention it in the your formula. Okay, straight away as we done it in the correlation, you can remove it. And the 0.148 is there. Then it is going to be, you can see that marginal difference is there. Huge difference is there. So this is a thing. And finally, standardized value, so standard error. Am I correct? typed it wrongly. I'm sorry for that. Standard error is that, and the standard
Hello. Sir, you are not audible. Dear participants, kindly hold on. I think there is a technical error from the resource person's point. We will wait for some time.
okay, ma'am, data with answer. Hello, ma'am, am I audible now?
Yes, sir.
Okay, where it was disconnected, ma'am?
Only before 1 or 2 minutes, that's all.
Okay, that output and all explanation and all, it is
Yes, sir.
okay. Any doubts so far on this?
I don't find any queries in the chat box, sir. That was clear.
Okay. Let me do the stepwise method last, as we have another 10 minutes. Go to analyze regression, click on linear, and enter stepwise. I will choose all the variables so that you will be able to understand whichever you have worked on it. Job. This This is not required if I'm correct. Okay, this is there, this is there, this is there. Okay, let me take it. Stepwise method I have enabled. Rest all it is going to be remain same. Just click OK. And from here itself, you can able to understand the model is coming. Can you able to see that? First one, predicting turnover intention alone. Then the second thing, it is turnover intention, perceived workload, and then it is going to be there. And similarly, whenever I'm going to use the different variables, it will tell you whether it is going to be measured or not, and how much R square change is there. So this is an in-depth analysis when we are going to use it, turnover internship with the perceived workload, and everything is going to be given very clearly. This is in detailed analysis when we are going for a stepwise method. So I think I'm done with the complete thing. I hope I have delivered what is required and expected. Okay. So any queries or anything, please let me know, and we'll stop here. The explanations and model and everything just remains same. There is no change in that particular order. Any queries or any questions? Let me save this.
Dear participants, please post your queries in the chat box if you have any. Otherwise, you can even unmute yourself and ask a question if you have any. So there's a question from one of the participants, Dr.
Standard
Anil
error.
Kanwasar.
Yes, standard error if I'm correct.
Please explain interpreting standard error.
Standard error, the model which is allowing. Okay, that's it. The error which has been allowed by the model itself. We are not defining any standard error here. Please make a note of it. We are not allowing any standard error. Standard error means the permissible amount it has been allowed. When it comes to the what you call the confidence level itself, we will telling that 95% confidence level, which means 0.0%, 5% level of error we are allowing ourselves from the researcher's point of view. Okay. Similarly, the machine will allow some error, okay, based on the model. When it comes to this model, it is 1.261. 1.261. When it goes to the next one, you can find it out. Okay, where is the coefficient thing? It is standard error is very, very minimal. Very, very minimal. So it is always better to keep the standard error at the minimum level so that my model is going to be validated more and I can get more citations. That is what I have told you. In this model, first model, we have included all the variables and we found that these three are not at all predicting, but associated, not predicting. Okay. But when it comes to this model, okay, when it comes to this model, only one variable we took it, which is strongly associated and predicted, and the standard error is going to be very, very minimal. I hope you understood. Okay. Now, even when I'm going to finalize my article on this conceptual thing, I will go with that particular thing only. I will remove all other things, and I will stick with that only one variable. Normally, it won't happen when you have a good and appropriate and validated data. Okay. I hope I have given a clarity on this. Yes.
Yes, sir.
Okay.
So any more questions, dear participants?
Yes, any questions or any doubts?
So participant is asking for your email ID. Can I share that?
Just a moment, ma'am. Yes, ma'am. They can. And the mobile number also if they need. But during working hours, it is not possible. That's one thing.
Okay, sir. I'll be sharing your contact details to the participants.
Yes, they can reach through my this Linktree thing. Everything it is available there. Okay, let me copy and paste it. When if you type it in Google, my full name, you will get this site is there. That would be useful for you. Okay, all the details, when you click on this, you can get all the aspects, how it has been working on, so on. Any queries? I'm happy to answer to your queries. Any doubts?
There are no more queries, sir. Participants are thanking for the informative session. So I think we can wind up.
Yes, ma'am. Any other aspects?
Yes, dear participants, you can even unmute yourself and give a feedback for the session. We had a continuous 5 days virtual workshop where we could learn about a research methodology, especially about SPSS, the hands-on SPSS. So kindly unmute yourself and give a feedback. We are expecting at least a feedback from 1 or 2 participants here. Participants are typing it in a chat box. Anyone at least can unmute yourself and speak.
Okay, ma'am. I think.
Yes.
Thank you. This is
Yes,
Anand
sir.
Kumar.
Good
I
evening.
am from Shimoga district, sir, working in Government First Grade College, Saraba.
Okay.
So initially, I found the invitation in one of the WhatsApp group regarding the SPSS hands-on workshop. So I found that and I got registered. And basically, I completed 1 week workshop already earlier before. It was a physical workshop. Now this is my second workshop. So I was little curious about the resource person. Indeed, I searched your profile in your institution, sir. Whatever the resource person's the profile I checked in your institution where you are working, and I found that you are specialized in data and analytics.
Yes, sir.
I really believe that yes, I could get some input from the resource person. Later on, I got confirmation that definitely the session will be a very beautiful. And indeed, it was very good session, sir, and it was very excellent explanation. The patients, the way of presentations, and the way of responding the questions of the audience, it was totally well enough, and it was really wonderful. And really thanking you very much, sir. And this SPSS, how much ever we learned, but still we will not get the perfection. Again, if you learn one question, you learn concept in one method, there will be a ambiguity little more, and that concept will be, outstanding. But anyways, it was very good session, sir. Thanking you, sir, and thank the institution, their organizers, and IKC coordinators, Navesh, madam, everybody. Thank you, sir.
Thank you, sir. Thank you for your valuable inputs.
Thank you, sir. Thank you, Anand Kumar, sir, for your feedback. And Napes, ma'am, had also unmuted yourself. Ma'am, if you have any feedback to give, you can unmute and give your feedback. Madam Napes.
YouTube link, it was not inactive. I'm trying actually all the recorded things. Shortly, it would be comes to active. 1 or 2 videos only I kept it. It is not in the professional manner. Hence, maybe we'll try in another 2 or 3 months. Time permits, everything goes well. I wanted to create.
And the YouTube video links of these recorded sessions for the 5 days workshop will be shared tomorrow. So I request all the participants to again go through the video and learn about the SPSS in detail.
Excuse me,
And-
Navya ma'am.
Yes, ma'am.
Ma'am, if you don't mind, if you before conclude the session, I would like to express few words. Can I?
Yes, ma'am, please.
Good evening, Gokul sir. I am Aisha Khanam from St.Teresa's Degree College.
Good evening, ma'am.
Sir, though I belong to the same college, but I was attending the session as a normal participant only. I wholeheartedly thank you for your wonderful presentation, sir, and the way you dealt with the queries of the participants was truly appreciated by all the faculty members, whoever attended the session. Thank you very much, sir. On behalf of our college, I wholeheartedly express my sincere gratitude to you for sharing your knowledge with us. Thank you, sir. Hoping to find the same cooperation in future also. Thank you very much, sir.
Thank you, ma'am. Thank you for your
And
appreciation.
how can I miss the organizer, Navishri ma'am? I congratulate you for successful completion of 5 days virtual workshop, ma'am. Ma'am, your efforts and Gokul sir's wonderful presentations have graced the workshop resounding success. Congratulations to both of you.
Thank you so much, ma'am. Thank you for your positive and valuable feedback. So any other participants, if you have any feedback to give, kindly give it. We have another minute to go.
Good evening, ma'am.
Yes, sir.
Yeah, myself, Bharat. I'm a research scholar in Mysore University, and presently I was working in Sheshatripuram College. First, I wholeheartedly congratulate the team. The team, you have done a very much good initiative with regarding to the SPSS, where I learned, because I doesn't know anything with regarding to the SPSS initially. So then I got to know that some basic information with regarding to that. So I'll thank Gokul sir for your valuable information. What was the information which you had given for us? Definitely we will use it for our future, whatever the our PhD process, what it is there. So for that we are using that, and we learned, and even like a 2-hour session, we thought it will be boring, and even we doesn't know how to interact or whatever the things we are going to learn and all. But basically we learned the 2 hours of session. It was very informative, and then it was very lively also. Okay, so I felt it is it should be like whatever the virtual we are done. It is we learned so many things with regarding with this. So thank you very much for you all, and once again I thank you for all the team. It is a team effort. So thank you all.
Thank you, Bharat sir. So once again, thank you, dear participants, for your overwhelming responses. So it's our core duty to thank the one who has added a value to our life. So it's Dr. S. Gokula Krishnan sir and all the dear participants who have attended all the day's session actively. So without waiting for anything, I will now call the student from final year BCom, Bhagyalakshmi, from final year MCom, to deliver the formal vote of thanks. Over to you, Bhagyalakshmi.
When life is sweet, say thank you and celebrate. And when life is bitter, say thank you and grow. Good evening to one and all. I am Bhagyalakshmi from second year MCom. On behalf of our college, I take this opportunity to propose vote of thanks to those who have directly and indirectly contributed to this national level virtual workshop on hands-on SPSS organized by PG Department of St.Teresa Degree College for Women. First and foremost, I would like to thank our resource person, Dr. S. Gokula Krishnan sir. We are really enlightened with your knowledge and presence. Thank you, sir. I would like to thank our principal, Dr. Sister Prema, and Vice Principal, Mrs. Malika ma'am, for your constant encouragement. Thank you, sister. Thank you, ma'am. I thank our academic coordinator, Mr. Rajesh sir, for your background support. Thank you, sir. I would also thank our beloved PG coordinator, Mrs. Navyashri ma'am, who took core interest in organizing this knowledgeable workshop. Thank you, ma'am. I thank the volunteer for your coordination. Last but not the least, I thank participants for their active participation. Thank you, one and all.
Thank you, Bhagya. So once again, I would like to thank the esteemed resource person, Dr. S. Gokula Krishnan sir, for delivering a wonderful presentation for all 5 days throughout the virtual workshop. And I also thank all the participants for your active participation and your overwhelming responses. So with this, I would like to wind up the session for the day. And the feedback link is being shared in the chat box. I request the participants to fill in the feedback form. The e-certificates will be issued within 1 week to your registered mail ID, and the YouTube videos, the recorded sessions videos will also be shared to your email ID. So I request the participants to have a patience till the e-certificates are issued, and we promise we'll issue that within another week. So if you have anything to tell, you can. Otherwise, we'll wind up the session now.
Okay, ma'am. Thank you. And I will take leave. Thanks for the opportunity. Thank you.
Thank you so much, sir.